Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq Iman bin Muhammad Tarmizi. So this is our circuit design for PBL assignment. The parameters value for voltage sign is 28.30 volt. The resistor R1 and R2 both 150 ohm and the load resistance is 5 ohm. The value of VCC is 40 volt and there are also two diode D1 and D2 and two transistor NPN and PNP. First, to obtain the input voltage, we must put the voltage probe at the voltage sign and we run the simulation. So the result is 28.257 volt. And then for the output voltage, we put the voltage probe at the load resistance and then we run the simulation. The result is 27.990. And lastly, to obtain the output current, we must put the current probe at the load resistance and run the simulation. And the result is 5.5980 ampere. So this is our simulation for the circuit. That's all from me. Thank you.
My name is Adam Abdullah bin Bakri and I'm gonna explain about the input of the graph. If we can see on the graph, it is full 360 of input and Q point is set near the middle of the load line. From this, we can get class A-B type of the power amplifier. This power amplifier is a compromise between the class A and class B amplifier. The Q point is above the class B but below the class A. The output conduct between 118 degrees and 360 degrees. If we refer to the note, we can get 25% to 78.5% of power efficiency of this type of class AB, and from the calculation we get 55.56%, and it is in the class of AB. The peak on the graph that we get is 28.257 voltage, but if we go through the calculation, we will find V peak is equal 20 multiplied SER2 and we get 28.38, and as we can see, it is near the calculation of the graph. That's all from me. Thank you.
Current, we will using current per time graph. As we can see, the amplitude of the current peak is 5.5980 ampere, and also the time taken to complete one circle is 1.5303 seconds. We can get the output current using the formula of V over R equals to I. Note that as the lead resistance is decreased, so the output current of the amplifier is increased. And then we will go to the calculation. As we can see here, the current for the peak we will calculate using V over R. The V is 27.99 over 5 is equals to 5.598 ampere, and then we can see that the answer is same from the simulation. And then for the current DC, we will calculate using the 2 over pi times current that we get from here. and then we will calculate, and the answer is 3.56 ampere.
Assalamualaikum warahmatullahi wabarakatuh. Today I will explain about assignment 1 BEKE 2333 Analogue Electronic. So I'm from group Can Do It. So we review our assignment question. So our assignment question is question number 6 about MTI radar, and the question want to ask, design a circuit to gain 80 watt output power and using push-pull power amplifier and BJT as a active device. So my friends already showed the simulation using this circuit and gain input voltage, output current and output voltage. So I will explain about the output voltage. So output voltage is at R3 in this circuit is R3 equal to 5 ohm. So the output is at R3 5 ohm. So the output voltage that we gain from the circuit is 27.99 volt. So after we get the output voltage, from the output voltage we can get output power using the formula output voltage square over 2RL. So RL in this equation in this circuit is R3 equal to 5 ohm. So we insert the value of V output and to R3. So the output we gain is for output for power output is 78.34 watt. Okay, after we get the power output, we can calculate the power efficiency. Before we calculate power efficiency, we must calculate the power input. Okay, after we calculate power input, we can get the value is 142.4 watt, and then we calculate the power efficiency equal to 45.01 watt. That's all from me. So thank you.